new project. This is our new project. Dimmer switch using 4017 IC, the main component. And then here we have the power indicator. So as we know that there is a power in the circuit. And then we have the driver, transistor driver D882 power transistor. Also with capacitor for a regular stabilizer. And then for our output, we are using this COB chip on board LED. This is COB LED. Usually used in a flashlight or house light. COB LED, chip on board LED. And for the power, we're using this 9 volts supply. So let us check. Let us test the circuit. Now we have the LED indicator turns on. So you can see the amp. What's that? LED indicator turns on. And then when I press the button, LED COB LED turns on and there's a light. And then press it again. This is now a much brighter light. And then press it again. Highlights, bright lights, full lights. And then another press. Again. Off. So you can see here it is, the switch is bouncing. That's why there is some sort of error. It must be little light, dim light, bright light, dim, much bright. So there is a switch bouncing, but the switch is serves its purpose. Dimmer switch. You can dim the switch. In figure 1, we have dimmer switch using 4017 IC. 3 steps. So our project is a dimmer switch using 4017 decade counter IC. And the power of the IC, 16 volts. 14 is the input clock. 10, 15 reset. 13 clock inhibit to be grounded, and 8 ground. Pin number 10 is an output connected to the reset. 7 output, 4 output, 2 output. So as you can see, it has a sequence. 2, 4, 7, 10. That is the sequence of toggling sequence. And then into our circuit, we are using 9 volt supply with a power indicator of 15K resistor with blue LED. Just to minimize the light of the LED, I'm using high value resistor 15K in order not to damage the LED, using this in series with the LED. Then we have the push button connected to the 9 volts, then to the pin number 14. And the initial state of the IC is grounded, pulled down to the ground by 100 kilo ohms resistor connected to pin number 14. That is the clock input. Pin number 2 is the first toggle switch or toggling output. 4, 7. So every time I press the switch, it toggles. So first initial state, when I press the switch, this pin number 2 turns into high level, or it will turns on. There is an output current here. With the use of the fast switching diode in series with the resistor, that is 220K to the base of the transistor. So this 2 is active by pressing the button, and they're causing the transistor to switch on because there is now a triggering current to the base, to the base emitter of this transistor, D882 power transistor. Because there is a transistor switch on, current now flows into the LED. This is the COB, chip on board LED, color white. So that is the LED we use. Current flows into the LED, to the collector, to emitter, then to the ground, because transistor now switch on. So the current now flows into the LED, to the collector, to the emitter, to the ground. So the purpose of the switch of the transistor is as a switch, also as a driver to the COB, chip on board LED. Let us see that. Where is that chip on board LED? Where is that? This is the chip on board LED. Okay? That is the D4 white. So it's high powered LED. So we need the high power transistor because the current to the collector is very high because of this high powered white COB LED. So this transistor is capable of handling up to 2 ampere of current, collector current that flows to the collector, to the emitter, then to the ground. So it is act as a driver to the COB, chip on board LED. So the first instance, pressing the switch will turn on the first step. It is a very dim light for the LED because we're using a high value resistor to the base. And then again, releasing it, it will latch, or it will turn up, and then pressing it again, the current now flows into the pin number 4. It toggles. This pin number 2 now is off, pin number 4 is on. So this one now is activate. We can now activate this part, the D2, 1 and 4, 1, 4, and then 100K resistor. turning on this transistor also, and then the result of the LED. So this LED now turns on also, but much brighter light, because the value of the resistor is 100K only. Unlike the 220K, the result is a dim LED. 100K, much brighter than 220K. And then press it again, it will turn off because it is latching. Press it again, it toggles into pin number 7. So the purpose of 4017 IC is it toggles. So this one off, on, off. If this is off, this is on. So this now is on. Current flows into the path switching diode also to the resistor 220 ohms. So less resistance. Switching on again the transistor, resulting into a brighter LED, bright light LED, because the biasing resistor 220 ohms is less. Okay, less current, less resistance, more current to the base, causing to have more lights to the collector or to the LED. And then press it again, it will latch, it will turn off, then press it again, it toggles into pin number 10. Since pin number 10 is connected to the reset pin, it will again cycle. So again, we press it again, it will turn on this 2, pin number 2, and then we have dim LED, and then press it again, it will turn off, press again, it will turn on. Now this one, this is now off, this is now on, for a much brighter light. And then press it again, it will turn off this one and turn on this 7 bright light because of less value of resistance to the. And then press it again, it will turn off, and then reset again, and then flow, and then cycle back to the pin number 2. So the purpose of 4017 is sequencer. It has a sequence. Where should be the first one to turn on? This pin number 2. Then again, it will turn off. Pin number 4, turn on. And then it will turn off. And then pin number 7, turn on, off. And then 10, reset back to the pin number 2, 4, 7, 10, 2, 4, 7, 10. So that's the purpose 4017 IC. It is act as a sequencer. And then this transistor is a driver to the LED, because this LED, chip on board LED, has a high powered amperage, so high powered LED, like so. That is the why is it we have this dimmer. The only error, there is an error, is due to the switch bouncing. Whenever we press it, sometimes it toggles faster. Okay? Sometimes it skip pin number 4 and then go to the bright light or dim light, and then to the bright light, skipping pin number 4. So that is some problem occurs here due to the switch bouncing. Let us now see the improvement of our circuit. I add the switch debouncing IC 7414. So in order to eliminate switch bouncing, so this is a debouncing IC. Let us again test. When I press the switch, so it has 3 steps. First, it is off. Then second, dim light. Third, bright light. brighter light, and then the brightest, and then off. So it is 3 steps dimming switch with the use of the bouncing IC. It is now we have this dimmer switch with no bouncing issues. 1, 2, 3. 3 steps. Dim, bright light, brightest. Dim, off, dim, bright, and the brightest. So we are now able to dim the COB or the chip on board LED. So this is now our dimmer switch circuit using 4017 and the bouncing IC 7414. Schematic diagram of dimmer switch using 4017 with 7414 debouncing IC. So this is the debouncing IC. So originally we have this portion with no debouncing IC, and the rest is the same with the new schematic diagram. This one is new, and the same with the power indicator, 9-volt supply. So with the use of this debouncing IC, we can see the current flow. Here pin number 1 is the input, the output is pin number 2, pin number 14 the supply, 7 is the ground of this 7414 IC. And then we are using a capacitor 47 microfarad 50 volts. So initially the current flows into the 2.2K and then to the 1.5K, charging this capacitor. So this is a decoupling capacitor, coupling capacitor. So it continuously charging. And then once we press the switch here, it will discharge through the ground. So it will inject a current through the pin number 1, and it causing this pin number 2 to output a current here. You're injecting now a current to pin number 14 of our 4017. So it goes like the same. Pin number 2 will turn on, and then it will turn on the LED dim, and then pressing this switch again, release, press release, and then it will turn on this LED again with actually we have 3 level of brightness, 3 level control level of brightness. Because of these 3 different values of resistor into the base of the transistor, as we mentioned in our previous discussion. So we have 3 level of brightness, and with the use of this debouncing IC, so every time we press the button, it will not skip the level of brightness of this white COB. Remember that this is a COB LED. First level is the dim, second is bright, and then the third is the brightest. With the use of this debouncing IC. This is actually a hex inverter gate. with as a debouncing IC. Initially, it is pull up high with pull up resistor, and then pressing the switch, pulling it to the ground, it will activate this debouncing IC, injecting a current to the input of this 4017. So the same scenario will happen. It will continue to toggle the LED, and then we have now the 3 level of brightness control. We control the 3 level of brightness of the LED without skipping the level. Homemade DIY dimmer switch using 4017 IC and matching with debouncing IC hex inverter 7414, driver transistor for the output COB LED, push button, and pre-style soldering, PCB layout, freestyle. And then here is now our output COB LED. I soldered the pin header for this output. We're going to use female jumper wires, and for the power 9 volts. for our output, let us test the pin header. Okay, and then the supply. Supply, and then the output. Okay, there is no other connection but the output and then the supply. Let us now check the lights. Okay, press. So we have three brightness control level. Okay, brightness control level 3, level of brightness control, or 3 steps. First, dim light, brighter light, and then the brightest, and then off. Dim light, brighter light, medium bright, brightest, then off. So this is now our project. 3 brightness control level dimmer switch for dimming the COB or chip onboard LED supply of 9 volts using 4017 IC, driver transistor, and then debouncing IC, push button, and some discrete components.